Hello, everyone. This is Elisa Baum. I'm GridGain Systems Senior Director of Product Marketing. We'll begin in just a moment, but first I'd like to conduct a bit of housekeeping. First, could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me okay? So let's see, hands, I see hands, thank you. Next, during this webinar, you will be on mute, but should you have any questions during the discussion, please go ahead and enter them in the questions field within the control panel. At the end of the discussion, we'll take time to answer as many questions as possible. And in addition, a recording of this webinar, along with the slides, will be made available to everyone within 48 hours after the event. I'd like to introduce today's speakers. We have Glenn Wiebe. He is GridGain Systems Solution Architect. And we also have Rob Meyer, who's the head of Outbound Product Management. They're going to be presenting adding speed and scale to Oracle-based applications, APIs, and analytics. And with that said, I will turn the floor over to our first speaker, who is Rob. Go ahead, Rob.
Thank you, Lisa. Good morning, afternoon, and evening, everyone. I'm Rob Meyer. As many of you on the call have probably also done at some point, we've all worked at Oracle, or at least sometimes half of us have. And so today we're going to be talking about a topic that's near and dear to many people's hearts, which is how you actually can add speed and scale to Oracle database-based applications or APIs or analytics, and when should you be doing it, and when does it not make so much sense. So if you get one thing out of this webinar, it means probably I explained at least one thing reasonably well. But it's that it's not just about the database when you look at performance and scalability or speed and scale. What's really happening is over the last decade or so, people have been adding all kinds of new channels, layering one system on top of another. So if you're a DBA or you own a particular application that is falling down because of the excessive loads, more likely than not, it has been getting created by some mobile or web or cloud or other channels that might be coming through an API gateway or layer. It's then coming through some middleware that you built maybe 10 years ago or more. That's then eventually hitting an existing customer packaged app and eventually hitting an Oracle or other database. And those loads are 10x or more, sometimes 100 times more than what the apps were originally designed to do, even with the scaling you expected to add, just because of the way we behave online. You know, we do a lot of searches for the best price before we make a purchase, and we purchase a lot more frequently in smaller amounts than we used to when we would drive our car to the store on a weekly or monthly basis. So that's the first challenge, which is just the amount of transactions and queries has gone through the roof. The second is when we're on some of these channels, it's not like we're talking to someone over the phone. We expect sub-second responses every time. And if you look at what that means end to end, when you work your way back to the API or even the middleware behind the API, that middleware needs to be sub 100 millisecond every time. And that's often impossible with all the other layers we've put between that middleware and that database. So it is often beyond the database where you need to deal with performance and scale. Okay. The second is we're dealing with a lot more data than we used to. And even if it were in the Oracle database, scaling up would be really hard with 50 times more data, especially all that other social machine interaction data that we've created outside of traditional transactions. Some people say we've gone up 10 times in the last couple of years, that 90% of the data didn't exist 2 years ago. Whatever the amount is for your company, the reality is there's a lot of data outside of Oracle where you also need performance and scale. And then you need to pull it all together with Oracle and non-Oracle sources. And somehow that query and that join and all that merging of the data needs to operate really quickly. The third big challenge is that even if you get the transactional side right, there are all these analytics that we used to perform on a daily basis or a weekly basis, where we extract, transform, and load data out of Oracle and other databases into a warehouse. Now we do it with Hadoop. Now we're doing more change data capture, more real-time streaming. But the point is, by the time you've taken the data out of all the sources, cleansed it, merged it, made it consistent, and started running the reports on top of it, the data is pretty stale. And now, in many new projects where you're trying to do real-time personalization, profiling, cross-selling, upselling while someone's shopping online, that is basically real-time analytics. And there's no way the existing infrastructure can support that, especially something like Hadoop, which is great at scale, but not designed for low latency. So there are really 4 challenges here if you take a step back. The first one is most databases were designed mostly for scale up, not scale out. There aren't a lot of horizontally scalable distributed databases. We're literally one of the 3 SQL databases out there that scale horizontally as a database. So there's no way you can handle that kind of increase of 10 to 100 times increase in load and continue handling it with scale up. Something's got to change there. The second is you have to fix the latency beyond the application and database, not just with the database. So now, no matter how much memory and specialized hardware and network cards, NICs you throw at your database deployment, it's just not going to fix the latency that's been built up across all these layers that are layered on top of it between your new channels and your database. The third is, even if you could fix all that, there's another problem with being able to change the existing applications fast. Most of the new entrants that have been coming into the business and disrupting existing industries, like Amazon, for example, can deliver new functionality in days or weeks. They do that because they're very well disciplined in API management techniques from Jeff Bezos down. There's a famous email from Jeff Bezos about who owns the API and how long it lives. So those kinds of shops have set the bar for the rest of the industry, basically saying you need to be able to deliver new functionality in days or weeks. You can't do that with applications that are built to be released in months or years. So somehow you have to layer on top of these existing apps the data, the events, the functionality, and be able to have that be flexible enough to change it quickly. And that means you need to build a layer for your data, your business logic, and your events that is that flexible. And then last but not least, you need to be able to add the real-time analytics. You cannot have 2 separate pipelines anymore, one for transactions and one that's ETL plus data warehousing or Hadoop or something else for analytics. The only way to actually do real-time analytics is to have the data you need in the same place as the transactions and running the analytics locally in place really fast in a way that can be injected into an interaction or even a transaction. We call that hybrid transactional analytical processing or hybrid operational analytical processing, otherwise known as HOAP. And so you need to figure out how to work that over time into your architecture. All of this is intertwined with every decision you make about speed and scale. Because if you make the wrong decision, you add the wrong thing. To improve a point problem with speed and scale, you might actually be painting yourself into a corner. You might actually have to replace that a year or 2 down the road. So I told you, if you can remember one thing, remember that it's not just about the database, it's about end-to-end performance and scalability. If you can remember 5 things, I would say this. If you're looking at fixing a point project performance and scalability problem, ask the 5 whys, which is what we always used to do when we were looking at business process improvement. Well, why is this a problem? Get back to the root cause of where you think the speed and scale challenge is, because it may be that that's where you really need to put your money, and it may be a lot cheaper. And we'll go through some examples of that. Second, optimize for end-to-end speed and scale. Anyone who's worked on a large-scale transactional or analytical system knows that you got to design end-to-end for speed and scale. You can't just fix one localized problem, especially when you hit the limits of network or disk or even compute. You have to design end-to-end. So look at the whole problem end-to-end, from the channels back to the database, and figure out how you're going to add that much speed and scale. Look ahead over many projects. This is a journey. Just being able to put in all the infrastructure you need to add the speed and scale and add the real-time intelligence and be much more flexible, be much more agile, or be able to change things in days and weeks, that's a multi-project initiative. So look ahead. Think about, for each project that you're doing where you're spending on speed and scale, how does it impact the other projects? Because otherwise you might have to unwind your original investment, replace some big servers, whatever it is. You don't want to do that. And then choose the right long-term Oracle or third-party options. We're going to spend some time on some of the Oracle options, but look ahead and think about what makes the most sense, because there actually are a couple good, really reasonable choices to make with the Oracle options that you have. We're going to start with the Oracle options, which are mostly about the application and database scale locally within the application users and a couple other areas, but also do help add scale and do help lower latency. So we're going to go through a few. I'm going to give you a summary so you can think about it. I've never been able to find an overall guide, which is partly why I put this together. Hopefully it helps, and comments are welcome. So always feel free to find us, comment back, and give some feedback. We've put a lot of this into a white paper as well. You'll find online. Lisa will probably send it to you after the webinar so that you have easy access to it. But let me start with some of the lower latency options, in particular the Oracle database in memory option. A little while back, Oracle added a feature where you could, through plain configuration, just through turning it on, add a second version of a row-based, disk-based table that was completely in memory and columnar in structure, which is great for analytics. So the idea is, for every transaction that comes in, the Oracle database updates the row-based table, commits, and also, as part of that transaction, updates the columnar table so that they're completely in sync with each other. If it's more a read operation, it goes to the memory columnar. If it's a transaction, it goes to the right. Makes each one very efficient. I would say this is probably the best implementation of this kind of feature, of in-memory feature, across the various databases for improving analytics. Columnar-based in-memory is probably the fastest thing you can do. It gets to a point where you don't even necessarily need to index in many cases to add speed, because it's so small and incremental. So it's very efficient, and it makes a lot of sense when you look back at you think about why they did it. Now, it's great for latency. It's not going to solve your scalability issues if you're trying to solve the size of your database or handle more write loads. It may actually improve incrementally. It'll certainly improve the latency of the reads. It'll certainly, it might make the existing infrastructure more efficient, but it's not going to give you 10x more performance gains. So think about it as a great option for lowering latency if you can add additional RAM to your boxes. Your costs are going to be the cost of that additional RAM, because you probably need to add it because you probably sized your servers to support your existing database, not a database that consumes that much more RAM. And second, you're going to spend 50% more above the Enterprise Edition license. A lot of the Oracle options are priced this way. If you go to the Oracle price list, it's easy to find. You just search for Oracle price list or pricing for a particular product, and it'll pop up. You'll see that a lot of the options are 50% more. So those are the major costs. You may have to upgrade your servers to be able to support more RAM too, because servers only have a limited number of DIMM slots for adding RAM. So you may hit the wall there as well. Use it when you have slow query performance, especially with your existing applications. It's a great option. If it's a relatively low cost option for you to add the RAM, not too worried about the enterprise licenses, and your read loads are going up relative to your writes, it might make a lot of good sense. I think one of the best options is Oracle RAC, or real application clusters. Back in the day when I was at Oracle, it started out as parallel server. It was great and complicated back then, but today it's a mature 20-plus-year-old technology that's pretty much proven, and it's a somewhat scale-out architecture, a shared something architecture that allows you to scale out your reads and your writes using software, not throwing expensive hardware to scale up. It has a couple big benefits. It allows you to add reliability and availability. If you add more machines and cluster them together, the individual instances can stay up and running if one machine goes down, and they're built for that. So it does add reliability and availability. And if you're scaling out on lower cost standard boxes, instead of investing in something like Exadata and scaling up to handle the same load, it's cheaper. So you're getting additional reliability and availability at a lower cost. I would say if you get into any situation where you need to add speed and scale, and you're weighing Exadata versus RAC, I would look at RAC first and scale out as much as you can. Now, that said, it is a shared something architecture. What that means is you have a global cache that coordinates things like locks and who's consuming what across the machines. So in order to do writes across the cluster, it allows all the servers to do the writes, but the lock is distributed, and it's relatively efficient. The best horizontal scalable architecture is a shared nothing architecture. That's how you really get linear scale out on low cost boxes. It's not an easy thing to do. People are doing it now, but at the time when RAC was written, that was not the case. And the way Oracle worked, they went with a shared something architecture with a global cache. So you need enough RAM on each box to hold that cache, and that generally means that since the cache will scale exponentially with the number of servers, you're probably going to have a low number of servers. The biggest cluster I've ever seen is about 48 nodes. That was back in 2017. That's nothing like a shared nothing scale out architecture on hundreds or thousands of nodes. And the limit is really the RAM. So this will cost you more. It's, like I said, an additional 50% above the Enterprise Edition license, like several other options. And you're going to have to invest in additional servers and more RAM per server to hold the global cache. But this is, in my mind and others, it's a logical first step for scaling reads and writes. And I would look at this first before other ways of scaling Oracle. The other option you have with Oracle is scaling up with Oracle Exadata. These are Sun boxes, good quality hardware. There are two options, the X7 II and 8. You can buy them in quarter rack, a full rack configuration. You can have disk or flash-based storage. The flash-based storage is smaller for about the same price. But those are your two options. The X7-8 is something like 30% more than the X7 II, but just delivers significantly better numbers in performance. The thing is, you're spending $1 million or more for a single rack. I don't recommend buying the quarter rack just based on what the numbers are. I think you're probably going full rack, and it's $1 million or more. And there generally isn't a lot of discount on hardware. So I think this is an option you use for the long term, when you don't have a choice, when your application is something like a package application, has a lot of PL SQL, and you can't slide something like an in-memory data grid in between the app and the database. You can't change the architecture any other way. You're locked in to basically your database application architecture. If you can't use RAC, it might, which I think is very rare, that might be the other reason you go for it. My advice, though, is look at it with RAC. Maybe go RAC first and then look at something like Exadata if you need the additional scale. It's more of a last option, not a first option. That's how I would look at it. Then there's Oracle Golden Gate. This was acquired by Oracle in 2009 as Golden Gate. It uses something called Change Data Capture, or CDC, off of the write-ahead log, where it streams out once and exactly once any change, any transaction that's written to the write-ahead log. Typically adds, as little as 1%, as much as 5%, maybe a couple more percentage, but typically you're going to see 2 to 5% additional load on a database, and in return, you can stream out to an operational data store and have all the reads point to the ODS, to the operational data store, with second latency, perhaps, sometimes more, sometimes less. So this is a viable solution for offloading reads. This is what many people did when when web applications started overloading apps. They started building an ODS, pointing the reads to the ODS, and keeping the writes going directly to the database, because the reads became the majority of the workload. So you could literally take the majority of the load and replace it with 2 to 5% load that CDC put on it. So it gave people a lot more headroom for growth with the same system. It's a good option also when, if you're trying to build out a new architecture that offloads reads, and you're trying to slide an in-memory data grid in between, if you can't intercept the writes easily to the database, and you can't do a read write through pattern where all the reads can be handled in memory in a memory data grid, it might make sense to have CDC streaming out and have the writes go directly to the database. This is actually why we integrate with Golden Gate today, why some customers use it, because they wanted to establish an in-memory read-only architecture, offload all the reads, but they couldn't intercept all the writes of all the applications. So they set up this kind of architecture. It is lower cost than Oracle. You can go look at the price list and figure out what the price would be for you. And it's a great option if eventual consistency is okay. In other words, if you can do a read and it doesn't interfere with your writes. If you do a read and an immediate write, and you're expecting that to be transactionally consistent, that is not the case. You can actually do reads while someone else is doing a write, and the latency could be enough to screw up your database. You would have to do a compensating transaction in that case, and you need to be aware of that. But there are several cases where eventual consistency is okay. And in that case, this could be a good option. And where it's not okay, or where you really want to completely offload and invest in a memory computing layer or a new in-memory data layer to do things like give you the flexibility to unlock the data you put in the memory data grid for new use cases, it may not be the best answer. And so we'll go through that a little bit later. Another acquisition by Oracle was TimesTen. They acquired them in 2005. It was a scale-up in-memory database that later has been sort of renamed TimesTen Classic. We'll go through what that means. Basically, it's a database, holds all the data in memory. There is a backup copy in disk, but there's no disk-based storage, active disk-based storage. All the data has to be in RAM, and it can only scale up as a single instance on a single machine. Oracle later built an option called, and if anybody can remember this, I probably owe you $1, the Oracle TimesTen Application Tier Database Cache. There is no abbreviation for it. Maybe some people call it the database cache, but that is the official name. Basically, it acts as a read-write-through cache database that can be installed locally with an application. The reads and writes happen to TimesTen Classic for each application that's pointing to it, thinking that it's the actual database. TimesTen Classic Application Tier Database Cache then asynchronously writes back to the Oracle database. This works well if this is the only path to the database. If it's not, then you can get out of sync really fast. Now, this is built as an async classic cache, not a read-through, write-through pattern, really. It has refresh both on the server side and on the TimesTen side for synchronizing Oracle database with TimesTen Classic. And it does assume in that architecture that the cache can get out of sync, that it needs to invalidate and refresh. It does also offer local disk-based backup and recovery for restarts, which is a good option for any cache because you don't want to have to overload the database when you restart and suck in all the data from the database for your initial load. It clearly lowers latency. It clearly offloads reads, and that may work very well for you. It does not help with scalability. The size of the database size of the data you'd be using in the application is limited to the amount of RAM you can have on that single machine. So it's not going to scale up as much as Oracle, clearly, which is doing disk-based scale on some big boxes. And it's not going to hold big tables on a local machine. So this is all about lowering latency. It does also, you have to realize this is not a perfect solution. It's going to pass through writes to the database, and if there are any triggers that invalidate the data, it's going to fail, and you're going to need to do a compensating transaction to get everything back in sync. If the data changes, Oracle, if a PL squeal or trigger changes data on the Oracle database, it will eventually propagate back to the cache, but it is eventual. So if you need immediate consistency, this is not a good answer. It costs 50% more of the Oracle Database Enterprise Edition license and requires additional RAM to hold all that data on the boxes that you're using it on. So it's good for eventual consistency and for lowering latency. It is not as scalable as a typical in-memory data grid option, which is a read and write through cache pattern, okay? And we'll go into a little bit more of that later. The reason Oracle TimesTen is now called Oracle TimesTen Classic in that database tier, the Oracle TimesTen Application Tier Database Cache is called really TimesTen Classic, is because in mid-2018, Oracle released true scale-out shared nothing in-memory database called Oracle TimesTen Scaleout. It is officially now, I think, a 1.0. It went GA then. It is a true scale-out in-memory database. In other words, it has true affinity-based partitioning based on foreign keys. For example, you can, in this first release, go up to 64 nodes, and you also have one backup node. So there are 2 copies in case you lose the primary. So 128 nodes total. It is still in memory only, does not use disk for storage. It uses it for backups. It is transactionally consistent. It's a true database. Has great support for Oracle SQL and PL SQL, probably the most compatible with Oracle. So that makes it the easiest, the best rip and replace option for Oracle database. If Oracle RAC is not enough for you and you want a lower latency, this is a great option. It does mean you're going to spend the same amount of money replacing your database. It costs exactly the same as the Oracle Database Enterprise Edition. It is a new license. You're going to be buying a whole new slew of hardware, albeit low-cost scale-out hardware with a lot of RAM. But you're still buying new hardware. So it's great for custom apps that have a lot of PL SQL if you're trying to add speed and scale to an existing app. It's great for low latency, large data set applications where the SQL, co-locating the SQL with the data works really well because it does co-locate SQL really well. It is not a good option if you have large data sets that you're trying to use with Java or some other coding language. Because in many cases, the large data sets need to be co-located with the code. In that case, you really need a more general purpose compute grid. So you should be thinking about if the network is going to be your bottleneck for those applications. That's why people use compute grids and in-memory data grids. But great product, a great 1.0 and a great achievement by Oracle. Let's talk about now some of the other options outside of adding speed and scale to the database. What are your choices outside of there from Oracle and from third-party vendors? In order to understand the first most popular option, you need to understand what an in-memory data grid is, or an IMDG, and how it works. So basically, caches evolved to the point where they could be put in between an application and a database, slid in between. To the application, they look like, hopefully, like a database. And then to the database, they somehow connect to the database and accept all the writes right to memory, and then pass the transaction through the database, and on successful commit to both so that they're completely in sync. We call that a read through, write through cache, or a read, write through cache. And there are various patterns of it. Ideally, it acts as the new database to the application. The application needs minimal change. Sometimes you have to rewrite the application. So for example, if it's a SQL-based application, ideally, which is what GridGain does, or Apache Ignite does, you just hand over new ODBC, JDBC drivers, and all the application needs to understand is SQL. In other cases, you might have to rewrite your SQL to perform key value operations, some kind of API call, and somehow tear apart the SQL and shove it into the in-memory data grid layer to interact with the database. But ideally, it's minimally invasive. The benefits are you keep your database. You add speed, you lower latency, you add horizontal scale on a shared nothing architecture, and several in-memory data grids do have that shared nothing architecture. So you get the speed and the scale, and you get the co-located computing. The biggest bottleneck with large data sets nowadays is the network. You can only move 1 gigabyte a second, roughly, over a fully loaded 10 gig network. 1 gigabyte a second, when you're talking about a terabyte of data, is a very long wait. The only way to solve that problem is to move the compute or the code to the node, to the data, and run it there locally and just return the results set over the network. That's why TimesTen Scaleout is TimesTen Scaleout. That's why in-memory data grids exist today, really for the co-located compute. That's one of the biggest pieces of functionality you can get out of an in-memory data grid. Over time, as you add more projects, you can scale your in-memory data grid out to other databases, to Hadoop, to mainframe. The more data you bring into the in-memory data grid, the more data you can use together, because you can perform any kind of query or compute across the in-memory data grid. This gives you a new in-memory layer for running other kinds of workloads against that data, because if the in-memory data grid is built right, it can provision new copies of the data, put them on separate nodes, and you can run your new compute there. And the in-memory data grid will handle synchronizing the data, keeping it all together. It gives you a new flexible data layer in memory with speed and scale that allows you to write your new functionality fast. So you're not just getting the speed and the scale, you're getting a place where you can run other kinds of analytics for real-time analytics. You're getting a place where you can provision the data quickly for new workloads, which means you can get new functionality out in days or weeks, ideally, not months or years. And that's why one of the big reasons, beyond speed and scale, why in-memory computing has become so important in new API management or digital business-related initiatives, because it gives them the flexibility, the agility to build all these new applications a lot faster. So with that said, Oracle does have an in-memory data grid. Oracle Coherence was acquired by Oracle in 2007. It was Tangasol. And at the time, it was a very good in-memory data grid. The problem is it has not really evolved since. The last dot release was really 3.7. That was in 2011. We're currently at 3.7.1. Oracle also has a database-related versioning where it bundles in with Oracle Database. It's 12.2.1.3. It's not up yet at the latest Oracle Database 18 or 19. It's an earlier release. It's really not evolving much at all. And so there were a lot of important features added to in-memory data grids over the last 8 years, like co-located, general purpose co-located computing or massively parallel processing for Java or .NET or C++ even. And Coherence just does really something called OQL, which is not even SQL, but it doesn't do co-located compute. And there are a whole bunch of other things around transaction support and pessimistic or optimistic transactions, or support for Spark or doing machine learning that it just hasn't added, that other in-memory data grids have been adding. So I personally cannot recommend the product. I think there are other vendors you should be looking at. It's not a competitive offering at this point. If you have an existing in-memory data grid, an existing Coherence deployment, and if it's not broken and you're just going to keep upgrading and performing as is, that makes good economic sense, but otherwise it's not something you should be using for a new project. In general, you'll be looking for something that's more than an in-memory data grid, because there's an evolution where you might add an in-memory data grid to a project where you need to add speed and scale. And instead of spending the extra money on the hardware and or software or database licenses, you might slide an in-memory data grid that runs on low-cost hardware and add that, lower the read latency, and unlock that data for new uses and go from there. You might use in-memory storage, an in-memory database that's part of the same platform to store the 90% of the other types of data, IoT data, web session data, for either real-time analytics or some kind of other application. You might use Spark, something like Spark, for stream ingestion, stream processing, and analytics, and manage the data in memory for that. You might do some deep learning and machine learning over time across projects. But as you build all this on a common layer, the benefit you get is you're bringing all your data together for all kinds of other uses. So you're probably looking for something that's more than an in-memory data grid if you look ahead and think about all the projects you need to build out. It's certainly the case for digital business initiatives. If you want to compare the different vendors, we've produced some comparisons on the GridGain site. This is the link at the top of the page where you can go read them. And I have to say, Gemfire, Gigaspaces, Hazelcast, they've certainly invested in a lot more in their product than Coherence has, including GridGain, of course, and Apache Ignite. So there's certainly plenty of content out there you can get from us, you can get from others to help with your comparison. I think in general, those comparisons are going to point you away from Coherence. So for those of you who are not familiar with GridGain, we donated the original code to the Apache Ignite project. It's something we've been working on for a good 4 years or so. And then we decided to donate to Apache, the Apache Software Foundation. It was something like the second fastest project ever to reach the top level status, and is now one of the top 5 Apache Software Foundation projects in terms of innovation, in terms of activity, both on the developer side and the user side. A few million downloads a year, downloads at the same level as an Apache Spark, for example. So it's up at that level. It's got all the functionality you'd expect around adding speed and scale as an in-memory data grid, a database for streaming analytics, and now for continuous learning or real-time incremental machine and deep learning. And it helps people not just add speed and scale, but add the real-time analytics, add this hybrid transactional analytical processing model, and automate some intelligence using machine learning techniques. What we add as a company are the production-ready releases, plugins for integration to other very popular projects. We spend a lot of time adding speed and scale to those plugins so that they work better together, like Spark. And we add security plugins, and we add deployment monitoring and management tools as well. And of course, we add the support and services. One of the things people come to us for is fast patching, within days, because the Apache Software Foundation does not patch very quickly. It's a multi-month cycle. And there are hundreds of companies that use us. There are thousands of companies that use Ignite. Okay, so one of the things that makes it different as an in-memory data grid, especially for adding speed and scale to Oracle, is that GridGain and Ignite, they're the only in-memory data grid with support for full-blown ANSI 99 SQL and for transactions. So you can literally slide it in between an Oracle database and an existing custom app and support the SQL that's there. If there are things that you want to change in the SQL to add some speed and scale, then you do that entirely in SQL. You don't have to rewrite your app to perform key value operations, rip apart the SQL, somehow shove it down into the in-memory data grid. So you don't have, it's the most minimally invasive option, and that's one of the reasons people choose it. It's also the most general purpose compute grid. Beyond supporting distributed SQL, the way it actually works, it's a very similar approach to TimesTen in terms of scale out SQL and how we partition data. It's a general purpose compute grid, so you can really partition in any way. And you can also push your code. You can run C++ or .NET or Java locally in co-located with the data across the nodes. And you can also use a host of different clients that add adds languages like Python to your to the grid. So there are a whole bunch of different options for running all kinds of applications or analytics or APIs and co-locating it or running it with the grid. And that's why people tend to adopt it as an in-memory data grid. It also acts as a full-blown distributed SQL or key value database. So you can store literally petabytes of data across a cluster. In fact, there is a petabyte cluster out there. One of the things that it does beyond being a memory-centric database that can store any amount in RAM and/or disk, it actually allows an immediate restart, which for regulatory reasons, some people need to be up and running no matter what within 3 to 5 minutes. And you can do that with a full-blown distributed database if it has this immediate restart off of disk and not it doesn't have to wait to warm up the memory. You can do that with something like GridGain. There's a very large bank that does that today, and they actually had to move off of Oracle to get that. There are also extensive streaming analytics support within the product. It's got the deepest integration with Apache Spark. People just started using the two together, and over the years, we started adding and contributing to Ignite to add mutable RDD support, data frame support, where we not only are the only full-blown data frame provider across the in-memory computing products, but we also accelerate the SQL. We do what's basically push down, where we will swap out Spark SQL commands under the cover and do push down of joins and things like that, so that the data doesn't need to come over the network to do the join in Spark SQL. We push down the join into the cluster. So that's really one of the reasons people use us in conjunction with Spark for in-memory data management, where they use Spark as the processing engine. So they basically replace HDFS, which is disk-based storage, with in-memory data management using Ignite. And then there's continuous learning. We've implemented and contributed several algorithms, and other people have contributed other algorithms to Ignite. We're doing all kinds of linear, multilinear regression, k-means, as well as deep learning, whether it's built-in algorithms or it's integration with TensorFlow. All of that is there in the framework today for doing machine or deep learning, where you can do it in memory, in place, incrementally, instead of having to move terabytes of data over a network, which could take hours, and then run full training on specialized infrastructure, which could also take hours. We can run it in place incrementally, which gives you near real-time incremental machine deep learning. So Wellington is one of many examples of people adding speed and scale to Oracle. They're actually entirely on Amazon. They have an Oracle RAC cluster that is their book of record. And in order to be able to add speed and scale, they added GridGain on top to create an in-memory investment book of record that they could do all their real-time analytics, so they could see the real-time position by asset class, by customer, and the overall risk position of all of their assets, which are about $1 trillion in assets, across companies and assets, both for portfolio management, for their customers, for overall risk management, and for regulatory compliance. They, by adding GridGain as an in-memory data grid on top of RAC, they were able to achieve about a 10x gain in performance, and they've gone to complete linear horizontal scale on top of RAC, which helps them with all the different types of compute that they need to do, both for the risk analytics and for regulatory compliance. So it was the SQL and the asset support that made it so easy to slide on top of Oracle RAC and build out this new infrastructure. I want to turn it over to a demo so that you get a sense of how this actually works. Feel free to ask questions. I'm going to start looking at some of the questions online now and try to answer some of them. I'm going to save some of the hardest for Glenn and I to take at the end. So Glenn, I'm going to turn the screen over to you.
Okay.
Let me just take the quick, let Let me find you and then share the screen.
Okay, well, while he's exposing my system to the world.
There you go. It's coming.
There we go. So, Rob talks about sliding an in-memory data grid in between the app and database, almost as if falling down, you could do this. Well, I'll let you judge whether it's as easy as falling down by the demo that I give today. In the real world, we find that people have challenges understanding how to do this with all the different data sources and the different consumers of the applications, the APIs, different tools that might be used, and the different patterns. So in the demo today, I'm going to show you how you can use GridGain and its web console to walk you through figuring out what you need for an in-memory data grid or in-memory database for your needs, for your data sources, and show you how we can easily create, config, and deploy those clusters. And then, I'll consume it in a couple different simple ways that hopefully you guys will recognize. So I'm showing on the screen the web console that comes with the GridGain product. And knowing that Oracle is the source of the database, and whether it's going to be directly, I'm going to mirror it with a cache, or it's going to be a source to feed me the data, either of those ways, I might want to start by looking at the database as the source to reflect what I'm interested in. So if I simply connect to an existing Oracle database, we introspect that backend system, see the schemas that we have available to us, and then looking through that, we see there are a number of tables in that schema that we could create replicas of in our data cache. And for very large data sets that might span in hundreds of millions, we want to partition that. We want to use that horizontal scalability to really get the speed and scale and processing power of those multiple instances working for you in that split join approach. Some data, however, might be best to be available everywhere. So we have the option of having some of our data being set up in a replicated fashion, which means on my 10, 20, 100 nodes, I have a complete copy of the countries, a complete copy of the departments. But for employees and job history, which might be large volumes of data, I'm going to split that up, partition that across the web, across the cluster. In both cases, these are logically one data source. It's going to be treated as a country, whether it's got 10, 20, 100 copies in the cluster, or whether it's the job history, and it's logically one thing, but it's split, where 10% is a split between each of my 10 nodes. They're all going to look the same. So having introspected and seen the data out there, I'm going to pull those in, and I'm going to give this some kind of name to keep track of it in my ORM. And I'll call that HR for the time being. And essentially what I have now done is I've imported a cluster, and I can look at that and see all the permutations and capabilities that I have available to me. So we see the various things like the country, like the departments, like the employees. And GridGain has done a good job of seeing, well, what are the different data source types, data types we have there? What are the key fields? What are the aliases? Can I create some indexes to reflect the kind of indexing that was in Oracle? So we have very quickly created a cluster configuration that matches our needs. There are a number of other features that I can play around with, and if you use the enterprise features, you'll see you get a lot of other things like data center replication and snapshot backups and recovery, etc. For the time being, this is all I need to do to create a in-memory data grid patterned on Oracle as a data source. So I would save my changes, I would download my project, and with a little bit of hand waving that I won't show you today, I will build that into a runnable archive, and I would start up my cluster. So I'm not sure if this is a great view, but this is essentially starting up my human resource for Ignite server that I was just configured for me on the web console. And if I'm ready to go, I can load the data into the cluster by using the pre-built loaders from Oracle. And this takes a little bit of time to spin up, but once it has done, we see that our data will then be loaded into the cluster. And while it's doing its work, I'll highlight that one of the enterprise level features that you'll want to have when running any kind of in-memory data grid, or in fact any solution that supports speed and scale, is having great visibility to what's happening in your backend platform. So with the GridGain web console, we have the ability to monitor what our various performance metrics are, the different measures of memory, latency, cache sizes, so forth. And you'll see that I indeed have a number of caches and associated SQL-based tables that have been loaded into memory. Now, we see we have our data metrics over here, but maybe I want to now interact with it as a client would interact. Well, directly from the console, we have a notebooking feature. So if we go in and pull up one of our notebooks, I see that someone has already written some queries for me. And let me just take a quick look and see what's in the countries cache. And there's our data right there. Now, other applications might be ODBC or JDBC based. If I was a database developer, now I previously was using Oracle's tool to write queries and look at the data. Now I might just use something like dbeaver. And dbeaver is available in many different views. This is the Eclipse-based view, but as you see, as I connect to the Ignite cluster, I have a number of, let me just disconnect and reconnect this. There we go. And I see my employees. I can look at the table, expand that out, and look at the various data types, or I might have written queries. And whether you are doing a simple query like select star from countries, or whether you're doing something more advanced with joins as part of it, you can do that all from the tool of your choice that you feel comfortable with. And if you are a analytics user, maybe you're a Tableau kind of person, you want to get a count of all the different types of users out there. So I want to count how many there are and do that by department. And this is all happening against my employees' cache. So if you look at this, you can see this is the Ignite JDBC driver, and it's as simple as changing that from Oracle to JDBC Ignite, and you're good to go. So that's almost as easy as falling down, wouldn't you say, Rob?
I don't know. I tend to fall down a lot, so it's hard for me to say. But it is pretty easy. I think one of the questions was really, and I answered it already, but one of the questions was partly around, okay, so how hard is it really to start using the different SQLs in something like GridGain versus straight Oracle? I think this was getting to the how much do you actually have to do, and the idea that you could just reconfigure a connection to point to, or had just add a new JDBC driver, ODBC driver to do the basic SQL commands. That's actually, you shouldn't take that for granted, because we're actually the only ones that do that. It was a lot of engineering on the Ignite project to make that a reality, and no one else has actually added that yet. So
yeah, and one other, I realized I was going to show, people who are not SQL necessarily, but maybe they're Python and they're machine learning kinds of experts. Well, it's very simple for you to interact with us. You simply have to import one small package, the PyIgnite package. You run that, and then at this point you can interact, create a new cache, put data in it, get data out, and without much effort at all, you now see that we have created a cache on the cluster. And what did I call that? Sorry, I called that the customer demo cache. And so there it is right there. And I wrote 3 records into it, and those are the 3 right there. So that's about as simple a Python example as you can get. And if you want Spark, we have a whole bunch of APIs: C, C#, .NET, Node.js, R, etc. So SQL is one huge community, but there's a new community out there as well, and it's there's more APIs, more technologies coming out there, and that's why you want to go with a platform that can scale out to all those different new uses as well.
Yep. I did have one question that came in about adding speed and scale. It was about TimesTen Classic, or really TimesTen, but it was talking about TimesTen Classic. Isn't TimesTen Classic, the database, the application tier database cache, acting like an in-memory data grid? And the answer is yes, it kind of is. It's pretty close. It's 80% of the way there. So you could say yes, it is, with a few exceptions. The first is, when it does its write, it doesn't actually assume that the reads are up to date. So if I'm doing a read, I might actually be refreshing from the Oracle database periodically, which creates a little bit more traffic, similar to the way something like Redis, a traditional cache, might invalidate the cache and refresh it. The second important thing to note is it doesn't scale out. So it's only as big as the size of that single instance. There's TimesTen Classic and there's TimesTen Scaleout. TimesTen Scaleout is only a standalone database. The TimesTen, all the other TimesTen options are TimesTen Classic. And so you'd need to do a combination. If you're really adding both speed and scale, you need to figure out how to partition your data across applications so each TimesTen cache is able to be small enough. And then you'd also have to add something to add scale on the Oracle side, like Oracle RAC or Exadata, which may be possible, but you're going to have to add up all those costs together and managing all those moving pieces and parts together. So you're weighing that compared to an in-memory data grid, and you have to decide which one is better for you in that case. But that's an answer to that question. I think we've run out of time. I don't see too many other questions here. Feel free to, I just want to point you to a couple other places, so maybe I'll just take over the screen really quickly. Once I figure that out. Okay. All right. So I wanted to say, if you could remember those few things, just as a reminder, remember to optimize for end-to-end speed and scale. It's not just about the database. Look ahead over many projects. Remember, you're playing for the end game. So everybody's excited for the Avengers. So look ahead towards the end game. Choose the right long-term Oracle and third-party options by looking ahead, and invest in the long run. If you have to spend the extra money to put in RAC now because it's the right long-term answer, do it. Same thing with an in-memory data grid. Make the investment to build that new layer, to put the data that you need for APIs in a single place, because by the way, APIs collect data from many places. The only actual way to lower latency for an API is to bring the data to the API and put it in memory. That's it. So eventually, to add speed and scale for APIs, you are going to add an in-memory data grid. It is inevitable. So look ahead towards these projects and think about whether making the investment now will pay off for the future projects, and make that call up front. And then start to invest in that in-memory computing layer, because you are going to need it, if not for digital business, then maybe for something like IoT or real-time analytics. It's basically required. So I did want to remind you also, there are a couple in-memory computing summits coming up. The first one is in June in London. If you're looking for an excuse to get to London, please take it. You can win a ticket to the conference for £20 if you go to this link here and apply. So please go up there, sign up, and then you can worry about getting to London later. But please come join us there. If you can't make it to London, come out to California in October or November. I think it's October this time. We'll be hosting in the Bay Area. And that's a multi-vendor conference. This is really the only major in-memory computing conference that happens, and we host it twice annually. If you're looking for other information, I've included some links here. You'll get this as part of the PDF slides, and you can go to the Resource Center. You can go to IMCS Summit, imcsummit.org, and get plenty of interesting recordings there from us, from other vendors, from customers talking about their projects. And you can always download Apache Ignite, or you can download the free new GridGain Community Edition, which is basically hardened Ignite that we're investing in to help with production Ignite projects, and also to get some other features in there that's sometimes harder to roll through the overall process. So feel free to go download it. Feel free to go look at these other resources. And with that, I want to thank Glenn for showing us the details of how easy this can be, and thank all of you for attending. And we'll see you at the next upcoming webinar, perhaps, which I think is monitoring and management. Maybe it's troubleshooting. And then we're going to keep hosting this database series, looking at some of the other ways to add speed and scale to other databases. So more on that soon. But thank you all for attending.